So this talk was just going to give you a bit of an overview of providers within OpenSSL, and this is the topics I'm going to cover. You know, what is a provider, and just talk a little bit about why we need them. I'm going to give some examples of how you might want to use them. Um, if you're familiar with engines from our older versions of OpenSSL, I'm just going to touch on that and explain uh, why we have providers and what's happened to engines. Um, I'll cover some deployment scenarios, some typical ways that you can deploy providers with your application. And then I'm going to go through the list of providers that are included with OpenSSL. And finally, just some content on how to configure and activate providers. So, first of all, what is a provider? So it's effectively a collection of algorithm implementations where an algorithm is some kind of cryptographic primitive like RSA or AES or SHA-256, something like that. Yeah, they come in two forms. We have built-in providers, or you can have them separately loadable. So if they're built in, then they're part of libcrypto or your application. There isn't a separate file to load as such. Or we can have these separately loadable modules, which will be either a .so file if you're on a Linux or Unix type platform, or a DLL if you're on Windows. Providers can be supplied either by OpenSSL. As mentioned, we've actually got 5 which come with OpenSSL, or you can get them from third parties as well. You can have multiple providers all running at the same time, and there is a stable ABI between providers, and that's quite important. And I will talk a bit more about that in later slides. It's important to understand that so each provider has algorithm implementations, but which implementation you actually run is chosen dynamically at runtime. You can actually have multiple implementations of the same algorithm available to you from different providers. So, for example, the FIPS and the default providers that we have both contain the same algorithms, and so which one is selected for use is chosen dynamically. And then another important feature is the key management capabilities that we have within providers. So each provider has its own representation of a key, which is internal to that provider, but then we can transparently export and import keys from one provider to another so that you can, for example, load a key in one provider and use it in another. So why do we have providers at all? It provides us the capability to add new algorithms at runtime. So this is quite important. This is really useful if you've got a third-party provider. You can actually plug in brand new algorithms that standard OpenSSL doesn't even have. It gives you some flexibility in your OpenSSL deployment. You can decide exactly which implementations you want to be using, and those implementations may have different characteristics. The stable ABI that I mentioned enables different release timelines for the OpenSSL itself and providers. So you can be using the latest version of OpenSSL libraries and a provider which is compiled against maybe an older version of OpenSSL, for example. And obviously it enables third parties to extend the capabilities of OpenSSL. So just to run through some examples of different ways you could use these. So an obvious example is regulatory compliance, and this is why we have our FIPS provider, which you'll hear us talking about a lot. It's there for the needs of regulatory compliance. The provider is entirely self-contained, and therefore we can validate just the provider to whatever regulations we have to adhere to without having to worry about the rest of OpenSSL. And again, because of this ABI, you will notice that not all of our FIPS providers that we have for all our patch versions are actually validated, and so you can use an older version of the FIPS provider, which is validated with the latest version of the libraries. Another example is PKCS11. So if you've got some HSM that you want to use, then you might use a PKCS11 provider, and there is one that exists. There's a link there on the screen to a third-party PKCS11 provider. And the whole architecture enables, because of the key management capabilities, the keys can be held entirely within the PKCS11 token, and OpenSSL itself doesn't ever actually need to access private key details directly. Another example here is post-quantum. As of today, OpenSSL itself doesn't have any built-in post-quantum algorithms. Obviously, there's a lot of work going on at the moment to develop the standards around these. There is a third-party provider already, the OQS provider, which you can go and download and use with mainline OpenSSL. And that enables you to get access to post-quantum algorithms. It integrates into our TLS as well, so you can use key exchange and post-quantum key exchange and encapsulation mechanisms and signature schemes and get them running with TLS. Other new crypto might be of interest to you. For example, say you're in an academics context where you're working with more sort of bleeding edge algorithms which haven't yet been standardized, or maybe you need algorithms which are specific to your nation or region, which don't come with standard OpenSSL. Perhaps you could get a provider for that, or even if in some kind of industry specific context where you need something very specific to your industry, which isn't of general interest, there could be providers available for that. And here we have the example of legacy. So obviously, over time, the usefulness of algorithms, some age, and perhaps they become insecure. You don't necessarily want all of your applications using legacy algorithms. However, some applications still need to be able to integrate with legacy systems, and so you can't just get rid of these legacy algorithms. So by pushing those things into a separate provider, it gives you a little bit more flexibility. For most applications, they don't need to have access. We can block access to those legacy algorithms, but for the applications that really need it, it can still be available. You may be familiar with the engine interface, which was available in older versions of OpenSSL. It's still available today, but it is now deprecated, and so engines are considered legacy. And they're similar to providers, but we do encourage the use. We encourage use of providers instead of engines these days. There were a number of problems with the old engine API. It was difficult to support simultaneous use of a default algorithm implementation and an engine algorithm implementation at the same time. You couldn't have competing implementations easily. They integrate at a very low level, and the mapping to our EVP APIs isn't always that straightforward. There are problems around passing complex objects between OpenSSL itself and the engines. Because those complex objects gets passed around, it can cause all sorts of issues if your engine is linked against a different version of libcrypto to the application. And lastly, there's just no clear key management capabilities within engines. So for all of these reasons, we've retired we've deprecated the engine APIs, and we now are using providers. So if you download the latest versions of OpenSSL, you will find that there are 5 different providers that become available to you immediately. The first one is the default engine. I'm going to talk about each one of these in more detail in a moment. The legacy and the FIPS modules for providers are both loadable modules, and all the other ones are built-in modules. The legacy is also available as a built-in, but by default, it's a loadable module. So the default provider, as I mentioned, it's built in. If your application or your configuration doesn't do anything else, then the default provider will be loaded and activated by default. So you don't need to do anything special to get the default provider. It will just be there and it will just work. So if you have an application which perhaps hasn't been designed to work with OpenSSL 3 and above, so it doesn't really have any awareness of providers, it should just work in that sense. The provider will be there and it will be available. However, if you do take steps to explicitly use some of the other providers or a third-party provider, whether that be via config or programmatically in your application, then you do actually have to remember to explicitly activate the default provider if you want to use it. It doesn't automatically activate if another provider has been activated as well. That's simply because in quite a few scenarios, you may not actually want the default provider at all. So it gives you that ability to not have it. I'm not going to read all of these algorithms, but suffice it to say that the default provider comes with a broad set of algorithms available covering all sorts of different operation types. So we're talking about digests and ciphers and MACs and KDFs and signatures and random number generators and so on. Lots of different algorithms. I'm just going to skip past all of those. All of that stuff which I just flashed up on the screen there, just to give you a flavor of the breadth of capabilities we have in the default provider. It's all documented on the man page that I'm linking to there. So please go and have a look at that man page. There are separate man pages for all of the different algorithms which tell you all about those individually. So the legacy provider, so this contains algorithms which are less common or for one reason or another are deemed to be less secure. We don't recommend these for normal use, and that's why they're separated out into a separate provider. But obviously, for compatibility reasons, you may still need to use them. So if you need to use them, then load and activate the legacy provider. You'll probably want to use it in conjunction with the default as well in that case. It is supplied by default as a loadable module, so a .so file or a .dll. But if you build OpenSSL yourself, then there's a configure option, no module, which will instead build OpenSSL with the legacy provider as a built-in. Got a smaller set of algorithms in there. They're shown on the screen. And again, there's a separate man page, which I've linked on the slide there. So you can, again, go and study the documentation for the legacy provider and have a look at the algorithms that are available to you there. So next we have the FIPS provider. All of the algorithms, or most of the algorithms in the FIPS provider, are validated to FIPS standards. Supplies a subset of algorithms in the default provider, and so it's usually considered an alternative to using default. So often, if you're using the FIPS provider, then you won't load the default provider at all. It's not loaded or activated by default, so you do have to take explicit steps to get access to the FIPS provider. There is a bit of complexity around doing that, and we've actually got a whole talk on the FIPS provider later, which covers exactly how to install it and set it up. If you do use it, you may notice some slightly different behavior for the algorithms in FIPS compared to in the default provider. So, for example, there's perhaps stricter enforcement of key sizes than are allowed in default. There might be restrictions on the types of groups and elliptic curves that are available. Some of the key generation methods might be different, and that could have performance impacts. So various things like that you may notice as altered behavior. You have to have a validated version of the module in order to be compliant, and not all versions of OpenSSL have a validated provider. Right at the moment, 3.0.0 and 3.0.8 are validated. There's a link there. The download page has the latest validation status, and that does change over time. And again, I'm going to cover more of this later in the talk later on the FIPS provider. But as I've mentioned, you can use the latest version of OpenSSL. So you could use OpenSSL 3.2.0 and use a validated version for an older version, so 3.0.8, for example. And again, it's got a set of algorithms. Here they are. Go have a look at the man page for further details, and you can compare the default provider and FIPS provider and see which ones are available in which ones. Okay, next we have the base provider. And this only contains auxiliary algorithms. So by which we mean these are sort of non-cryptographic algorithms, such as encoders and decoders. So algorithms which serialize keys to a file or read keys from a file, for example. That can all be done with encoders and decoders and are available in the base provider. The reason the base provider exists is for use in conjunction with the FIPS provider. We wanted to keep those things outside of our FIPS validation, so we separated those algorithms out into the base provider. It's designed to be used in conjunction. So it's perfectly acceptable to load both FIPS and base, and that's the normal way of doing things. Not loaded or activated by default, and is supplied as a built-in module. It's worth noting that all of those auxiliary algorithms are also available in the default provider, so you don't need to load both default and base, one or the other. Okay, and those are the encoders and decoders and auxiliary algorithms that we have within the base provider. And again, there's a man page. Please go take a look at that. And then the final provider that we have is called the null provider, and it has no algorithms at all in it. You might wonder why that's useful. It is useful, and it's usually used to block the automatic activation of the default provider. So as I mentioned earlier, if you don't do anything with providers, you don't have any explicit config or explicitly load it programmatically, then the default provider will just automatically load itself. And sometimes you don't want that to happen. We'll come back to this later on when I'm talking about the FIPS provider again. I'll give an example of where that can be used. It's not loaded or activated by default, and it is a built-in module. Okay, so I'm next just going to go through some deployment scenarios, some examples of ways that you might set up your providers for use when you're using your application in a real deployment. So the simplest scenario here is just you have an application, it's linked against libcrypto, and you're using the default built-in provider. Nothing particularly clever about this, nothing particularly special. The default provider is already there. It will load, it will activate. Away you go, just start using it. This diagram shows you basically the same thing, but we've thrown libSSL into the mix as well. So you've got an application, it's doing some kind of TLS or quick work, and is linked against libSSL and libcrypto. This really is just showing you that the provider is a libcrypto concept rather than libSSL. So you load your providers, and that was all configured around the libcrypto, and libSSL just uses them. So if your application uses libSSL, I'm not going to show libSSL on the rest of my diagrams, but you can imagine that it's there if your application uses it. Okay, so here's the typical deployment of an application that is doing FIPS work. It's going to load the FIPS provider module, a separate loadable module, and use it in conjunction with the base provider for those encoding and decoding algorithms, which is built in. And here we have an application which has loaded the legacy provider. It's loaded legacy as a loadable module. And typically you're going to use that in conjunction with default because you're going to use some up-to-date algorithms and maybe some legacy algorithms at the same time. Typically, that's what it's going to look like. Okay, so here's an example of using a third-party provider. Again, you're typically going to use this in conjunction with default. So here we've got the OQS provider. So you're trying to use some kind of post-quantum algorithms. Usually you're going to want to use some classic crypto as well at the same time. And so we're going to load both. And here again, yeah, just the same thing, but this time instead of using OQS provider, we're going to use PKCS11 provider. Again, probably you're going to want to use this in conjunction with default. And here, finally, we have an example where an application is doing something custom. It wants its own provider. And this can be built into the application. So a built-in doesn't have to mean just built into libcrypto. It can be built into your own application. You don't have to have a provider and a separate loadable module to do this. So maybe you want to do some kind of custom encoding or decoding of keys. And so you could use a custom built-in provider to do that. Right, so config files. So we're just going to cover a little bit about how we can load and activate providers via a config file. I'll talk a bit later in my later talk about the FIPS provider because there's a bit of additional complexity that you need to be aware of if you're going to use that. And yeah, just to mention that point again, that if you load something other than default, then you need to load default as well if you want to use it. So OpenSSL will automatically try and load a config file if it can find one when you first start to make OpenSSL API calls. It's going to look in one of two locations. The first thing it will check is your OpenSSL_conf environment variable. That is assumed, if it's defined, it's assumed that it's pointing at the location of a config file. And so if that exists, it will load it and it will use it. Failing that, if the environment variable isn't there, it will fall back to a compiled in default location. So it will try and load a file called openssl.cnf, and that will be in a directory called openssl_dir, which is where openssl_dir is a value determined at compile time. It is platform dependent, so you need to run, if you run the command openssl version -d, it will tell you what your value of openssl_dir is for your particular platform. So look at that directory. Inside there should be an openssl.cnf file, which will be the fallback configuration file if you don't have your environment variable set. So here is about the simplest config file you can get for all it does is load and activate the default provider. In that sense, it's kind of redundant because you don't really need a config file to do that. The default provider will load and activate anyway. But we're going to use this to build on in the following slides. So we start at the top there, OpenSSL_conf. So this just says the OpenSSL configuration is in a section called OpenSSL_init. And within, you can see the OpenSSL_init section a little bit lower down there. And that says providers. The provider configuration is in a section called provider_sect. And then within that section, we have one provider. It's the default provider, and the configuration for the default provider is in the default sect. And there is only one thing that you can configure about default, and that's whether to activate it or not. And we have an activate equals 1 line, which says load and activate the default provider by default. Okay, so this config file does the same thing, except it additionally loads the legacy provider. So all we've done here is we've modified that provider sect to add a line which says legacy equals legacy sect. And again, there's only one thing you can configure about that, and that's whether to activate it or not. So we add in an activate equals 1 line. So now we have both the default and the legacy provider loaded and activated by default with this config file. So one thing to note about that activate equals 1 line is it's not sufficient to set it to 0. That catches a few people out. In fact, the value isn't significant at all. You have to have a value, but what that value is isn't significant. We recommend to set it to 1. But if you actually want to not activate by default, then you actually have to either comment the line out or just delete the line. And that's it for this talk.